Gizmos. Oh, those are fun. Don't you guys love gizmos?
Hey guys, page 4, we're just going to continue. Okay, so again, the big picture that we're kind of working towards is we're just trying to find an equivalent expression to what is provided in the problem. And we're just trying to create a more simplified version of what's given to us. And we have a couple of ways to get us there. One way is using our trig identities. And if we can memorize the first one, we can arrive at the other two simply by dividing every term by either sine squared or by cosine squared. And then we also use our trig, our inverse trig, or sorry, our reciprocal trig functions to make our substitutions. We talked about different methods of cleaning up some expressions. Factoring is one, expanding is another one, and also getting everything in terms of sine and cosine. Sometimes that kind of helps us clean up certain expressions. Okay, so we're just going to continue trying to find a way of matching and cleaning up. So okay. Okay, so we left off with number 6. Let's look at number 6 here. Cosecant squared minus cotangent squared. I'm looking at this. That reminds me of a trig identity there. So is there any way for me to rearrange this cotangent squared minus cosecant squared? And if I can, what does that equal to? 1, right? If I take this equation and if I subtract cotangent squared to the other side, then I get cosecant squared minus cotangent squared. And that matches with this, and that's equal to 1. Okay, does that make sense? All right, so we're just taking this identity and rearranging it, and we're trying to find something equivalent to cosecant squared minus cotangent squared. And imagine ourselves subtracting cotangent squared from both sides and getting that to match what's equal to 1. I'm sorry?
How do you know it's 1 again?
Okay, right. How do you know it's 1? So we know this is true, right? 1 plus cotangent squared equals cosecant squared. So let me write that down. So what if I subtracted cotangent squared from both sides?
Well, it would cancel out on one side.
Okay, let's try that. So good, it'll cancel out on one side. What's going to happen on the other side?
I know the square root of that x can cancel. Square root is the square and the x can cancel out here.
You mean these right here will cancel out?
Yeah.
What if we just put them next to each other? Because I'm just subtracting them, right? Okay. So does this help?
It's kind of like my
I'm just rearranging it to get something that is equivalent to this. So what's cosecant squared minus cotangent squared equal to? Equal to 1. So we can say that this is equal to 1. Does that make sense?
Oh yeah, it's just a formula like rearrange.
Right, we're just rearranging that formula to get it to clean up to be something that's equivalent and simpler.
Okay, thank you.
Yes, you have to memorize the first one. And the second and third, you shouldn't have to memorize it. You should be able to arrive at them. Okay. So if I divide everything by sine squared, I can get to this one here. If I divide everything by cosine squared, I can get to the second one.
Right, so really just have to memorize the first one and the second and third. I don't have the second and third one memorized. I just have the first one memorized, and I just derive the second and third based off the first one. Okay, number 7. Cosine squared over 1 plus sine squared. Okay, so normally I would say let's get everything in terms of sine and cosine, but it's already in terms of sine and cosine. So there's nothing much that I can cancel out. And there's not much I can do with that 1 plus sine x, but there is, but whenever I see a trig that's squared, I'm always thinking maybe there's an identity that can allow me to make some progress. So if I see cosine squared, I'm thinking, well, maybe I can use a trig identity to get this to be in a different form, and hopefully that will kind of jumpstart the process of, finding something similar. So what can I replace cosine squared with? Right, if I'm just rearranging this equation to get cosine squared to be equal to something that is equivalent to it. So if I subtracted sine squared from both sides, then cosine squared is equal to 1 minus sine squared. Okay, so let me just put this on a separate sheet so I can just have more room to work with here. Okay, so based off this identity, I know cosine squared is equal to 1 minus sine squared. It feels like we're making progress because at least we have the numerator and denominator in terms of the same trig function. But can I do this? Can I just cancel the ones out and take out one of the signs? Okay. Because what's preventing us from being able to just cancel things out? Something else. It's because of the minus and plus, right? Because we have terms that are added and subtracted. I cannot take things away if I have terms added and subtracted. They are linked in ways that prevents us from just reducing. Now, if it was just everything multiplied, then I can reduce. Yes, question. Why is subtracted at the top? So I'm just trying to find something equivalent to cosine squared. So if I see cosine squared, I want to find something equivalent to it, and I see that I have a trig identity available to use. So if I were to get that cosine squared by itself, I would subtract the sine squared over to the other side. So cosine squared equals 1 minus sine squared. Right. Okay. So we know we can't cancel out, so that's good. Now, we talked about yesterday that this is something that we can factor, right? We can factor this using what? Difference of squares, right? Difference of squares. If I have 2 perfect squares, I can break them down into their perfect square root parts, and then I can do difference of squares. Okay, but here this is sine squared x. So if I break it down, if I break sine squared x into sine x, then what's my factored form for my numerator?
1 minus sine 2x, 1 plus sine 2.
Well, the sine 2x is really sine squared. So that sine 2x is really just basically it's like x squared, right? So it's basically
1 minus sine x, 1 minus plus sine.
yeah, 1 minus sine x, because we've already broken that sine squared into sine and sine. Yeah. So do you see how before we couldn't cancel out, but now can we cancel out? Yes. Okay, because this 1 plus sine x is protected by multiplication, right? There's nothing that's being added to this parentheses, so it's safe. Okay. So that's as simple as we can get. Let's see if we can find a match for it. Okay, number 8. Sine x plus cosine x divided by sine x cosine x. Again, I can't cancel out, right? That plus sign is preventing us from doing anything. Sorry, reducing. Okay, however, we do have a potential strategy here that I haven't talked about from yesterday. And I want to show you something on this card here. If I have, let's say, let me show you a simple example. If I have a plus b divided by c. If I only have one term in the denominator and multiple terms in the numerator, I can always split this up into what? Two separate fractions, right? I can do that if there's only one term in the denominator, but multiple terms in the numerator. I can't do it if it's like, right? If it was like c over a plus b, I'm stuck. I can't split this up into individual fractions. But if I have this, multiple terms up top, only one term in the denominator, I can split up into individual fractions. That could potentially be a way to get this expression to look like something else, and maybe that will help jumpstart our reducing efforts. So you see how there are multiple terms up top. Below, I know we see sine and cosine, but they're connected, so we can kind of think of it as kind of one term. So I'm going to split up into individual fractions here. See if that will help me get this to look like something else. So now within each fraction, we can reduce, right? Because before we couldn't because there's something that was attached to it. But now these are kind of independent fractions that we can kind of reduce individually. Okay, so what do you see here? Okay, now the sine x goes away from the numerator, but what remains?
1 over cosine.
Good, it's 1, right? It's not a 0, it's a 1. Okay, and here I can take out a cosine, and what's left up top? A 1. Okay, so let's think about, can I get this to clean up even further? What's equivalent to 1 over cosine of x? Secant, right? It's the reciprocal of cosine. Can I reduce 1 over sine? So secant. So let's see if that is something that shows up as one of our options. Okay. I'm sorry?
Why is there an addition?
Because from the previous term, right? There's a plus sign in between, so we're just carrying that over. Okay, number 9.
This would cancel.
So this is similar to number 7. How is number 9 similar to number 7?
1 term on top and 2 on the bottom.
Okay, good. All right. What else? What else? What is it about this? What can we
Factor.
It's one of the identities, right? Eventually we're going to factor, but right now can't do much with factoring, but it is an identity that maybe we can rewrite. Maybe that cotangent square can be rewritten as something else. So if I rearrange this equation, if I get that cotangent square by itself, what cotangent squared equal to?
Cosecant plus.
-1, right? If I want to leave that cotangent squared as positive, I'll leave it on the left side and I'll subtract the 1 over the right. Okay, so cosecant squared -1. Okay, we got to resist the temptation to try to cancel things out, right? This minus sign is preventing us from just getting a clean reducing to happen. But at least we know we're making progress, but at least the numerator and denominator are matching in terms of their trig function, right? It's good. All right. What's next? What can we do with this cosecant squared x minus 1? Factor, right? Difference of squares. Factors out to be cosecant x minus 1, cosecant x plus 1. Okay, matches up perfectly. Reduce. We do have a match. Okay, I think these, this one may feel a little easier here. What's 1 over tangent? What's the cleanest form that we can get? Cotangent, right? All right, what about 1 over cotangent? Tangent. Cosine over cotangent. Anyone have a strategy to take as your first step? Yeah, rewrite cotangent, right? Anytime I see something where, oh, looks like something that I can quickly do to get cosine, just to rewrite in terms of cosine and sine, I'm looking at that cotangent. Sorry, cosine. And how can I rewrite cotangent that will help me match and reduce? Okay. I have a complex fraction that looks messy, but I know I can bring this up to the top by reciprocal, right? So reciprocal will allow me to get that denominator to shift up to the top because I'm really multiplying the top and bottom by sine over cosine to allow for the denominator to completely go away. So now I have things on the same, I have my expressions on the same level. It's easier to see where the relationship is. Anything I can do here, cosine times sine over cosine. Good. Numerator and denominator are matching. I can take those out. I'm just left with just what? This side.
Fine.
Okay, what we're doing right now is really just getting used to all these different ways of cleaning up and reducing. It'll help create this this foundation that we need when the problems and the expressions get more and more complicated. But we're learning the basics now and just seeing all the different ways that things can clean up and reduce. And okay, all right, cotangent squared plus 1. Does that look like anything? No, that's a perfect match with one of our identities. No need to rearrange. 1 plus cotangent squared x is simply cosecant squared x. Should be able to find a match. So this goes to the second page as well. So we have 2 pages that we're going to work through here. Some are easier than others. What's 1 over cosine? Yeah. Right. 15 is very similar to what?
7 and 9.
Yeah. So basically identical to 9, right? You're just canceling out a different, but the same steps. Get that numerator to use an identity to replace that cotangent squared with something equivalent to it. Factor. Okay, oh, right, so I skipped that step because it was similar to number 9.
Oh.
I just wanted identities, yeah. Mhm. All right, 16. All right, anything stand out here? Mm-hmm. What's sine squared plus cosine squared equal to? 1, so I can place that with 1. So what's my cleaned up version there? 2. Everybody okay with that? Right, just making a substitution and seeing how that can allow us to clean up. Okay, 17. There's an identity here. What's secant squared minus tangent squared? 1, right? If I rearrange it so that I subtract secant tangent squared to the other side, I get secant squared minus tangent squared. That's equal to 1. I'm going to replace this with 1. Therefore, that leaves me with 0. Letter O. Okay, so these are becoming more familiar because we're seeing kind of repeated strategies here. So hopefully we can kind of try these on our own here. About 19. Mhm. 20 is probably similar to our factoring, right? Find an identity, difference of squares, reduce. What can I replace tangent squared with? Yep. If I get tangent squared by itself, I can subtract 1 to the other side, secant squared minus 1. Again, we're not ready to cancel out. We got to factor that numerator before we can do anything.
Okay, we're gonna replace what's inside the parentheses with. There's still a what left over.
Change and to secant.
Okay,
It just.
right. So whenever I see anything squared, I'm always looking at my identities to see if there's a replacement that I can do. Right. So tangent squared is equal to subtract that one over, right? So secant squared.
You can only change it to secant.
I can, that's right, because of these identities, right? Because I'm only restricted to these identities for now. Okay, the negative stays. So -1. Okay, do you guys remember the setup here for 23? What can we do to get this looking like a simpler separate? Yeah, good practice. Yeah. Okay, reduce. One's left over. One over cosine is secant, one over sine is cosecant. Okay, so if I want to get 1 minus secant squared by itself, that means I got to subtract the secant squared over, which means I got to move the tangent squared over. So 1 minus secant squared x is equal to what?
Minus tangents.
There we go, right. So if I just rearrange to get this to match here, so 1 minus secant squared x must be equal to negative tangent squared x. So I got to move that tangent squared over to the other side to make it negative.
That's right.
Yep, that's. One minus cosecant squared, if I rearrange this equation to get 1 minus cosecant squared x, that cotangent squared has to go where? Other side, negative. Yeah. Okay, 3 times sine squared plus cosine squared. What can I replace that with? 3 times 1, which is 3. Okay, so I wanted to spend time finishing those notes, and then let's talk about today's notes. I find it to be easier because you're just looking and finding a replacement. I don't think it's too bad. So let's spend some time looking on page 6. Is that right? Page. Sorry. Yeah.
Yeah, page 6. So co-function identities are basically showing that there is a shifted relationship between certain functions. Remember how when we were talking about sine and cosine graphs, how they are basically, we can always shift a sine graph into a cosine graph by just moving it left or right. So these are the relationships here. Sine and cosine can be shifted to become like each other. And tan and cotangent have that shifted relationship, and so does secant and cosecant. So they're basically off. They're all kind of off by pi over 2. So anytime I see sine of pi over 2 minus theta, that's really just shifting that sign to make it equivalent to cosine. So cofunctions are translations of the same graph shape. So cosine and sine have the same shape. Tangent and cotangent have similar shapes. They're just, one is positive, negative, and the other is negative slope. And secant and cosecant are just really built off of sine and cosine. Okay. Good. The next one is to go over is even and odd identities. Okay. So cosine is an even function. Which means that if I were to look at a cosine graph and I were to fold the cosine graph over the y-axis, the cosine graph is going to overlap each other. Okay, and cosine and secant are going to be even functions, which means that if I were to put a negative variable into cosine, it's the same thing as the cosine function. Here's a algebraic example of that, and that's y equals x squared, right? Y equals x squared is considered an even function because if I were to replace an x with a negative value, that negative just basically goes away, right? If I do -3 quantity squared, it's still same as 3 squared, which is 9. So that kind of has that same relationship. Cosine and secant also, if I insert a negative, it'll just basically go away. Okay, just the negative goes away, just like the negative would go away with a parabola, okay, or any x value that I plug in. Okay. So if I know that these two are even functions, that means the remaining 4 are odd functions. Okay, so odd functions means that if I were to put a negative into the angle measure of sine, what's going to happen is that negative is going to stay, and that's the same thing as multiplying a -1 with the sine function. So basically, that sine of negative theta is basically going to create a reflected version of the sine graph. So to make it a little bit easier to work with that negative, because that negative inside the parentheses is hard to merge with other things. But if I know that it's the same thing as -1 times sine, then that negative in front is a lot easier to combine with anything that comes after. If I want to multiply negative sine with a -4, the two negatives can just combine and reduce. Okay, and that's the same with all the other trig functions. So basically, cosine and secant are positive, or sorry, even, and that will make it easy for us to remember that, okay, the other 4 that's not cosine and secant must be odd. I have some notes on this, but I don't know if it's worth going over. Basically, well, I'll just go over one thing here. An odd function is similar to like y equals x cubed, meaning that if I were to replace a negative x into that x value, that negative is going to stay. Negative x times negative x times negative x is negative x cubed. And basically, I can pull that negative out in front. So it's the same idea here. Sine, cosecant, tangent, cotangent. If you see a negative inside that parentheses, you can just pull that negative out in front. Think of it as a -1, and then you have a much easier time combining and reducing with other parts of the problem. Okay, so let's go to the bottom of the page. I'm not going to basically, because what I have under these boxes is basically I'm just copying this over again, and we can save time by not doing that. We already have these notes to work with. Okay, so we'll continue to refer to the top of the page as we make our substitutions and simplify the expression. Okay, so cotangent of x times tangent of negative x. So I'm gonna worry about turning it to something similar a little bit later. I want to deal with this tangent of negative x first. Tangent of negative x is the same thing as what? Yeah, negative tangent of x. It makes it a little bit easier to work with. That anything inside the parentheses, inside a function is hard to work with, but if I can pull that negative out in front, then it's just a number that I can multiply with anything in front or outside the function. Okay, so now we're just dealing with cotangent and tangent. What can I do to see what can cancel or reduce? I can rewrite that cotangent, right? Cotangent is the same thing as 1 over tangent. The reason why is because we have this property available to us. If I have tangent of negative theta, I can rewrite this as -1 times tangent of theta.
We have to remember all.
Hmm?
We have to remember all the.
Let me get back to you with the cofunction identity, but I think we should be okay here, right? So if you can just remember cosine and its reciprocal is even, then the other 4 is odd. With even functions, the negative just disappears. With all the other 4 trig functions, the negative remains. Just basically move that negative in front. Yeah. So. All right, so we know cotangent is 1 over tangent. We know negative tangent. We can just keep that at the negative tangent. We're just trying to get these two match up and pair up here. What can we do here? Toss them out. I'm just left with what? Negative. All right, cosine of theta, I'll leave that alone, but what's secant of pi over 2 minus theta? Okay, so let's go and look to see a match here. Secant and cosecant have that shifted relationship, so I can replace that secant pi over 2 minus theta with just cosecant. Okay, so now it feels more familiar. What can we do to get those to match up a little better? Is there anyone that I can rewrite? Yep, cosecant is 1 over sine. So cosine and sine doesn't cancel out, but I can merge it into the same fraction. Does that remind you of anything? Yeah, questions?
What happens to
What happens to pi over 2? Well, we have a perfect substitution for secant of pi over 2 minus theta, right? So if you look over here, up at the cofunction, secant of pi over 2 minus theta can be completely replaced with cosecant. Right, what'd you say? Cosine over sine is the same thing as cotangent. Yes, yeah. Okay, so for the next 5 minutes, let's continue working through. Let's look at page 7. Let's see. Okay, well, let's skip 9 through 16. Maybe we'll come back to that to review. I just want us to practice with the even and odd here. But really, you're just finding a substitution for it and replacing it. So let's look at, let's try to do the odds. Okay. Okay, so sin x, I'm not going to do anything with that. That's as simplified as I can get. So I'll try to bring up the page so we can see here. Cosecant of negative x, what can I replace cosecant of negative x with? Negative cosecant. Cosecant I can rewrite as 1, no, or negative 1 over sine. And what's that going to reduce to be? Just negative 1, right? So our answer will either be 1 or negative 1, which is going to show the work to lead up to that. Okay, 19. Cotangent of negative x can be replaced with cotangent of negative x, same thing as what? Negative cotangent. Okay, so I'm just making my substitution. Cotangent of pi over 2 minus x, there's a cofunction for that. Tangent. Okay, what's negative cotangent times tangent? Maybe it's make it a little bit easier to see if I rewrite that cotangent here. What is this? What does this reduce to be? Well, yeah, because yes, you're right. I can write cotangent as cosine over sine, but I'm always looking around to see, you know, what's a better fit, right? So in this case, I want to rewrite as 1 over tangent because I already have a tangent. It makes it easier to match and pair up. Okay, let me talk about 21 here. I talked about that square. Let me talk about that square for a moment. What does the square mean? What is that square doing to the function?
It's multiplying by itself. Yeah, it's not the one where it keeps it even.
Yes, but before we deal with the even and odd functions, what does that square do to the function, though? Or what does that square affect? I'm sorry. Again, let's not worry about the negative. I just want to talk about in general. If I see a square in this location, what does that mean? Okay. Double, or it's squaring what? It's squaring
Sine.
the entire function. Okay, the entire function. Okay. So because I just want us, because sometimes we get thrown off by that square. Like, what does that mean? What that really means, it's a shorthand way of saying that I'm squaring the entire function. Okay, that's what it means. Okay. So if I see that sine square, I know we got to deal with that negative, but right now, that squared is kind of getting in the way of allowing us to see what is really happening. So I'm going to rewrite that squared outside. I want to place it outside so it's kind of out of the way, and also it doesn't confuse what it's doing. Okay, it's basically squaring the entire thing that we see in front of us. Okay, so now we can more clearly kind of just focus in on what we're dealing with here, right? Okay, what do you know about sine and negative x? Negative sine of x, right? It's an odd function. I'm still leaving that square there. I'll deal with it later. I'm just wanting to get what's inside the parentheses to be a little bit cleaned up. And what do you know about cosine and negative x? This positive cosine. Now, if I were to square a negative sine x, what's going to happen? Positive. So even though sine of negative x is an odd function, that squared is going to force it to be positive, and that's going to turn it back into sine squared x, or sine x squared. Now, what does that look like to you now? That's the trig identity, right? Give it a 1. Okay, we'll do some more practice with this tomorrow, and then we can go into 4.03. This is where we're going to start putting things together and expanding our problem a little bit more. Okay, come and get your phones.
Oh, sorry. Say for physics, that's my birthday.